On the 21st of February 2024, a new 5th-gen fighter took to the skies. The Turkish Aerospace Industries TF Kaan is Turkey's first domestically built modern fighter, and as we shall see, it marks the beginning of an ambitious program to refit Turkey's military with nationally produced equipment. So what is the TF Kaan and what is it likely to be capable of? To understand the TF Kaan, it is necessary to look at the ambitions of Turkey's military. The TF Kaan represents one of the first steps towards Turkey's broader goal of becoming militarily self-sufficient. The domestic design is one amongst many which have recently been announced. Turkey also plans to replace the T-38 supersonic trainer with what has been referred to simply as the Hurjet national jet trainer, whilst the Hurkus turboprop will serve as the prop trainer. They also announced 2 concept helicopters, the T-625 utility and the T-129 attack helicopter. All these ambitious projects will be designed and produced within the country, with minimal reliance on foreign companies. The emergence of the TF Kaan thus represents the first and perhaps most important part of this whole endeavour. Nicknamed the National Combat Aircraft, or MMU, the program first began in 2010. On the 10th of December that year, the Turkish Defence Industry Executive Committee announced its intentions to design a national fighter capable of replacing the Block 50 F-16s and eventually work alongside the F-35. It would be operational within the following 2 decades and replace the F-16 fleet during the 2030s. In 2011, Turkish Aerospace Industries, or TAI, together with Turkish Engine Industries, were responsible for conceptualizing and planning the new aircraft, researching possible designs, and generally taking the lead on the project. In 2013, TAI reported that the conceptual design phase was complete, and in 2015 several aircraft configurations were proposed. The first, known as FX-1, was a twin-engine design similar to the F-22. The second, FX-5, was likened to the F-16 with a single engine and similar configuration. The third design, FX-6, was based on the JAS-39 Gripen, featuring a single engine and forward canards designed for higher agility. The first design, the twin-engine FX-1, would win the selection process. In 2016, the contract for design and development of the concept was once again given to Turkish Aerospace Industries. With the equivalent of $1.8 billion in funding, they would be responsible not only for the aircraft, but for setting up all necessary infrastructure needed to produce the aircraft domestically. BAE Systems of the UK had been chosen to assist with the development of the aircraft, providing engineering assistance. A request for proposal was also published for an engine, with a requirement for the engines to be produced in Turkey. Several jet engine manufacturers, including Hurjet, manufacturer of the EJ200 engines used in the Typhoon, and Rolls-Royce, showed interest in the project. In 2018, General Electric, through its local Turkish partner Turkish Engine Industries, made a convincing argument that GE products would be better suited, given their wider OEM support, proposing the F-110 engine used on the F-16 for the prototype. However, the final contract for the engine remains up in the air. In 2022, it was said that a possible deal with Rolls-Royce was on the table, but that the primary concern was still producing an engine that Turkey had the intellectual property rights to and would be produced entirely in country. In 2019, the first concept would be unveiled to the public. The TF Kaan was revealed to be similar in design to most other 5th-gen fighters, drawing inspiration from the F-22 and crafted for stealth. Then in March 2023, the first prototype of the aircraft was rolled out and would undergo a series of ground tests and research, including wind tunnel testing, ejection seat tests, using a Martin Baker design, and studying the radar cross-section. This would culminate in the first flight on February 21, 2024. This maiden flight saw the aircraft reach an altitude of 8,000 feet, traveling at a speed of 230 knots before descending and landing with the aid of a parachute. The flight would last 13 minutes and was put down as the first of what will become a series of prototype tests, consecutively testing the aircraft at higher altitudes and speeds. And one can presume this will also include test flights for specific tasks, such as aerial refueling. Next, we will look at the aircraft's capabilities. As with other 5th-gen fighters, Turkey has remained hesitant to release any information regarding specifics, although we can make some educated guesses about the Kaan. Firstly, the prototypes will likely use two F110 GE129 engines, the same used on their F-16C Block 50s. The GE129 model can produce 19,500 pounds of thrust. This engine has led some to assume that the aircraft's top speed will be between Mach 1.8 to Mach 2, with a service ceiling of 55,000 feet. However, the production aircraft will probably use a different, locally produced engine, so this may change. It is also suspected that the aircraft will be capable of supercruise, as this was one of the points of interest highlighted by Turkish Aerospace Industries when in talks with Rolls-Royce several years ago. One can presume that supercruise capabilities, found in most fifth-gen aircraft, would have found its way into the design, although time will tell. Among some of the more interesting pieces of information released about the aircraft were details of airframe materials. The fuselage would be built with titanium and the nose of aluminium. Coating part of the aircraft will be a composite carbon thermoplastic, supposedly the same material produced by Turkish companies for use on the F-35. This material is claimed to significantly reduce radar reflectivity while also remaining extremely light. Keeping with the intention of a lowered radar cross-section, the aircraft sports two small internal weapons bays, one on either side of the fuselage. These appear to be for smaller Fox 2 missiles. Under the aircraft is a larger internal weapons bay, suggesting room for up to 4 larger missiles. The frontal aspect of the aircraft is indeed like the F-22, suggesting a lowered radar image from front on. This would give it an edge in beyond visual range combat. When it comes to stealth missions, obviously both the side and rear aspects are also important when flying into enemy territory. Given the Turkish government's investment into the aircraft so far, we can only assume radar cross-section tests have yielded satisfactory results. Also critical for such a project is the aircraft's reliability and build quality, given the stresses such an airframe is likely to undergo. The Turkish program seems to be rather promising so far, and given the track record of producing a high-quality, low-observability combat drone, known as the TB2, capable of both Air Force and Navy carrier use, they have proven experience. The program has the ambitious goal to replace the F-16 fleet within roughly 10 years. Turkish armed forces must have a high level of confidence in the Kaan design and likely see it as at least an equal to other Western frontline fighters. Like the South Korean KF-21, the hope for the Turkish program appears to be to use the TF Kaan as somewhat of a middle ground between a stealth air superiority fighter and a multi-role aircraft like the F-16. Turkey has long planned to equip with the F-35, and the Kaan has been designed with this in mind. It will, somehow or another, be capable of integrating with the F-35 fleet in a complementary fashion if the opportunity to acquire F-35s presents itself. In terms of armament, it has been confirmed that the TF Kaan will be capable of carrying several common Western missiles, namely the Meteor. However, emphasis has also been placed on primarily using Turkish-produced missiles, of which there are several. These will include the short-range infrared Merlin, the mid-range active Gökdogan, the long-range active Peregrine, the MAM-T anti-tank missile, and the Somcruise missile. Other precision-guided munitions will also be possible to equip, most of which are either produced in Turkey or modified with guidance kits produced in country. Inside the glass cockpit, the aircraft includes a command AI autopilot with sensitivity to pilot consciousness, a domestically produced AESA radar, helmet-mounted display, ANA 3 combat drone control system, and an electro-optical tracker capable of 360-degree coverage. All of this will come at a high price, roughly $100 million per unit, unless export customers also begin to invest. This makes the TF Kaan more expensive per unit than the F-35 export model. Despite this, the price has not dissuaded Turkey. This is likely because the TF Kaan can do what the F-35 cannot, and that is natively integrate with Turkish systems, namely drones, mission systems, and weapons. What will be interesting to keep track of is the engine which will find its way into the production version of the aircraft. Thus far, Turkey has shown interest in 3 potential designs, one from Rolls-Royce, one from Turkish company Kale, and one from a supposed non-NATO source, likely Russia, although China may also be on the table. The addition of new engines may change the capabilities of the aircraft. After all, the F-110 in the prototype is not designed for stealth. Turkey claims it wants an engine with 35,000 pounds of thrust, although producing high-performance turbofans is easier said than done. Few countries can consistently produce such engines, and most turn to the likes of America or Russia for assistance. Even China, with its rapid technological advancements, struggles to produce turbofans capable of matching the high-quality Russian engines many of their older aircraft were delivered with. Thus, for Turkey, it is not impossible to domestically produce an engine such as they desire, but it will be hard. Reaching the £35,000 thrust requirement is only one aspect. Given it is a stealth fighter, it must also be heat-shielded in such a way to reduce IR signature, and shaped and integrated such that it deflects or absorbs any radar signal that paints the aircraft. Finally, manufacturing tolerance must be extremely strict to produce long-lasting, reliable engines. Just as with any engine, tolerance for heat and friction can make or break a design in the long run, leading to more repairs, engine changes, longer times in the hangar, and ultimately less aircraft in the air at any one time. For now, the TF Kaan will continue to undergo flight tests, progressively upping the altitude and speed tests, likely achieving its first supersonic flight later this year. As of now, the plan is to manufacture 3 prototypes over the next 2 years, each slated to take to the sky consecutively each year. The first production aircraft, which will have mission systems not currently in the prototype, is planned for rollout in 2025, with its first flight planned for 2026. In just over 5 years, the first 10 combat-ready aircraft in Block 1 configuration will be introduced from 2030 through to 2033. Then in 2033, there are plans for mass production of Block 2 aircraft, outputting 24 units per year until 2040, then Block 3, and other future programs will take over. Turkey plans for the aircraft to serve into the 2070s, with regular upgrade programs and modernizations. News of the TF Kaan was received in the West with some skepticism. Many 5th-gen proposals have been made by other countries, yet the infrastructure needed to produce these aircraft successfully remains a serious barrier. Despite this, the TF Kaan does appear to be a serious attempt at a homegrown multi-role aircraft, with a focus on lowered radar image and air-to-air combat. It also serves as a rather interesting example of how a country can pivot from reliance on foreign to domestic military equipment at a price and production scale capable of competing internationally. What makes this perhaps more interesting than its contemporary designs, such as the South Korean KF-21 and the Chinese J-20, is just how ambitious the Turkish plan is, putting their money not only on a new aircraft, but an entirely new ecosystem, including missiles, guided munitions and drones which they believe will match Western arms. America, Russia and China have decades of experience producing aircraft. Thus, whenever a smaller country attempts to produce an equivalent aircraft from the ground up without the same history of aircraft production, it is sure to be a challenge. Just as with the South Korean KF-21, only time will tell just how effective this design is. But it nevertheless serves as an example of what a nation can produce when motivated.